Welcome back to Matea Valley Calculus Tutorials. Today we'll be talking about how to solve limits, specifically indeterminate forms of limits, using L'Hopital's rule. This will be most convenient when you start using the ratio test. Now, L'Hopital's rule states that if the limit of an expression results in 0 over 0 or infinity over infinity, the limit is called indeterminate. And then L'Hopital's rule can be used to evaluate these limits and expressions. Now, what L'Hopital's rule really is the limit as x approaches any number of f of x over g of x is equal to the limit as x approaches any number of the derivative of f of x over the derivative of g of x. So, let's attack some examples. The first example, a fairly simple one, we have to first check the limit as x approaches 0, sine of x over x. We must first check if it's in indeterminate form so that L'Hopital's rule can be used. So, when 0 is plugged in, it does give us an indeterminate form of 0 over 0. So, L'Hopital's rule can be used. Now, we take the derivative of the top of limit as x approaches 0, limit of sine of x, cosine x, limit of x is 1. This, when 0 is plugged in, cosine of x is equal to 1, so it would be 1 over 1 equals 1. And that would be your answer. Let's attack another example. So as the limit of x approaches infinity, 5x minus 8 over 3x plus 1. We have to check once again if this is in indeterminate form. So the top does go to infinity, and the bottom does as well. So yes, this is indeterminate form. And L'Hopital's rule can be used. So, we take the derivative of the top as the limit of x approaches infinity. Derivative of the top is 5. Derivative of the bottom is 3. And we get 5 over 3. And that is the answer. It's quite simple. Let's try to attack a harder problem. The limit of x approaches 0, as x approaches 0, of the square root of 4 plus x minus 2 minus x over 4 all over 2x squared. Now, let's check if this is in indeterminate form. The top does go to 0, and so does the bottom. So this is also indeterminate form. And L'Hopital's rule can be used. So we take the derivative of the top, which would be 1 over 2 square root 4 plus x. Negative 2 goes to 0, and negative x over 4 becomes negative 1/4, all over 4x. But when we plug in 0, this is still 0 over 0. And we must use L'Hopital's rule once again. So we take the derivative of the top, which would first be negative 1/4 4 plus x to the negative 3 halves. Negative 1/4 will go to 0, and 4x would go to 4. Now we can, after further simplification and plugging in 0, we get negative 1 over 128 as our answer. There will be times where you will have to use L'Hopital's rule multiple times. Now, let's look at our final example. The limit as x approaches infinity of x times e to the negative 2x. Right away we can tell that this is not in indeterminate form. So it's not 0 over 0 or infinity over infinity. So what we have to do is to get it in indeterminate form, so we must rearrange. So we try to get this in indeterminate form. So we move it around a little bit and we get x over e to the 2x. Now, this is in indeterminate form as it is infinity over infinity. So now L'Hopital's rule can be used. So now we take the derivative of the top, which would be 1, over the derivative of the bottom, which would be 2e to the 2x. Now, we get this approaches 0 because as the bottom becomes infinitely bigger, the whole thing becomes infinitely smaller and closer and closer and closer to 0. There will be times where you have to rearrange the limit so you will be able to use L'Hopital's rule and get it into indeterminate form. And that is L'Hopital's rule. Thank you for listening.